Hi, welcome to the watsonx education. My name is Anshupriya Srivastava and I'm from the Learning Content Development team. This is the seller presentation and I will be walking you through it. IBM watsonx represents the latest offering and innovation available to IBM clients to provide businesses with a complete AI platform for their needs. watsonx has three components: watsonx.ai, which is the studio for training and tuning ML models and foundation models; watsonx.data, and watsonx.governance. This deck is a guide for sellers on how to identify watsonx.ai opportunities and progress them. You should include this slide only when using content that needs to be shared only with IBM and business partners. Here you can see the content that we will be exploring today. AI today is $100 billion business that's expected to grow to nearly $2 trillion by 2030. According to Gartner, the global spending on artificial intelligence or AI software will reach an impressive $298 billion in 2027, and companies are expected to increase spending on AI to 35% by 2027. AI has seeped into almost every facet of our personal and professional lives in ways many are not probably even aware of. An AI conference is a good place to be to feel the excitement around the promise of AI. Clients will hear about all the good that AI offers across industries, from new generative models, improved customer interactions through chatbots and customer service menus, to proactive medical analysis, fraud mediation, improved supply management, and everything in between. But the fact is that AI's success does not always come easy. The buzz around AI today is all the foundation models and generative AI. One very important thing to remember is that a solid foundation in machine learning and traditional AI, the lessons learned, techniques used, and the life cycle processes all do carry over. This slide shows that IBM is recognized as a leader in artificial intelligence in the marketplace according to top analysts such as the International Data Corporation, that is the IDC, Gartner, and Forrester Research. Generative AI represents the latest innovation in the long history of the artificial intelligence journey on data representations. It began with expert systems and early inference engines in the 1980s using symbolic representations of data. The modern era of AI and machine learning began in the 1980s and culminated in deep learning in the later part of 2010s. These models required a massive amount of labeled data to train. The resulting models were targeted for specific tasks, and while these models could be successful, they were expensive. Finding and labeling sufficient data is an expensive task. These models were not easily transferable to other tasks and not initially thought about when model training. Solving different tasks, even though they may be related, required another set of labeled data and retraining. Such task-specific learning models were not scalable and became expensive. This is analogous to training an intern to understand and interpret legal documents versus medical content. These industries have different vocabularies, ways of thinking, and ways to resolve gray areas, among other differences. New ideas, innovation, and new techniques began to emerge in the late 2010s to provide the next leap in AI modeling, foundation models, and generative AI. Unlike the traditional machine learning and AI models, foundation models are trained on massive but unlabeled data sets and use self-supervised learning. Foundation models have a much broader base or a foundation. Today, large language models or LLMs, which are a type of foundation models, have proven to be very useful, especially in initial applications for areas in natural language processing or NLP tasks. The speed, scope, and scale of generative AI's impact is unprecedented. ChatGPT burst into the public landscape in November 2022 and within 1 week had 1 million users and passed the 100 million users mark in only 2 months. In comparison, it took much longer for any popular social media to reach 1 million mark as shown in the diagram on the left side of this slide. ChatGPT's impact is raising public awareness of the huge potential and capabilities of generative AI. However, the impact is not just for public sector. Goldman Sachs noted that generative AI could raise the global gross domestic product or the GDP by 7% within 10 years. The IBM Institute for Business Value Future Trend Research noted that executives expect 48% of their employees to use generative AI to augment tasks within this year, 2024 alone. IBM aims to provide an artificial intelligence platform whereby enterprises can unleash the power of generative AI in a safe, customizable, responsible, and explainable manner that is controlled and owned by clients instead of a general purpose black box. Now, why are foundation models so powerful? At a high level, foundation models are pre-trained. Unlike other machine learning models that clients will have to train, foundation models come pre-trained with a huge and diverse unlabeled datasets. Clients can use them as is. Foundation models can be further tuned with small sets of labeled data for downstream tasks for which they were not built. Foundation models are not specific to any tasks and can be used to apply to many tasks, such as generating code snippets, answering questions from legal, medical, architectural, procedural, analyzing sentiments, and many more. Foundation models are quite good as is and require much less additional data to provide additional refinements to better support specific needs. The most typical tasks today are natural language processing tasks. These types of foundation models for these language related tasks and data are called large language models or LLMs. Note that LLMs is more than how humans communicate. For example, programming languages also fall into the domain of LLM. ChatGPT is based on an LLM. The strength of foundation models is that they are generally quite capable and are easily adapted to perform specific tasks with a fraction of the training required to build a task-specific traditional AI model. Foundation models can be easily adapted to take over downstream tasks for which they were not originally built for using labeled data. In the simplest form, a foundation model platform knows sufficient general knowledge to be able to generate meaningful responses to various tasks such as translation, summarization, finding answers, etc. Given a sufficiently large set of training data without the expensive labeling, a foundation model can usually perform quite well at specific tasks. A foundation model platform provides a prompt mechanism where users can input some text and generate a response. The foundation model will take the input and generate the desired output. Users can also provide task-specific fine-tuning with data and input specific to the task. Foundation models can be easily adapted to create the appropriate task model for extraction, summarization, or to find answers to general questions. Foundation models require a small set of labeled data to fine-tune for specific tasks, and they can easily be adapted for many different tasks with much less effort than traditional AI. Enterprise clients will likely want to adapt foundation models to their specific use. Successful vendors provide ease of fine-tuning for their foundation models. Here you can see how clients can leverage foundation models and generative AI to support these very 5 popular use cases, like summarization, extraction, generation, classification, and question answering. The use cases are described for 4 business areas: that is in customer care, digital labor, IT operations, cyber security. And of course, there are several other opportunities. With foundation models, the AI industry has arrived at the era of generative AI. As the name implies, this is used to generate entirely new content. Gartner defines generative AI as AI techniques that learn a representation from artifacts from data and use it to generate brand new, completely original artifacts that preserve a likeness to the original data. Generative AI is trained on foundation models, and the most popular ones are trained on LLMs, which are specifically effective in natural language processing or NLP tasks. This is made popular with the success of ChatGPT. ChatGPT is great for so many things, such as creating personal performance, summary reports, and resumes, passing bar exams, generating original write-up on various topics with little input, providing great chatbot interactions. But is this what businesses need from generative AI? Despite its powerfully demonstrated capabilities, there are various risks associated with foundation models. Some of them are: foundation models like LLMs are quite good for general consumption. Quite good, however, is not that useful for businesses. Foundation models are complex, and to train them for specific tasks requires good AI skills and talents. The creation of foundation models requires a massive amount of data as well as significant compute resources. Some of the models are now using multiple billions of parameters. Now, building models to this scale is only possible for a few enterprises with massive R&D budgets available. This means that it is concentrated on a small number of vendors. As shown with ChatGPT, it's quite easy to misuse foundation models to produce malicious code or content. How can a business control its foundation model that is they are using? How can they ensure it is safe and that any data passed into it will not be misused? Most foundation models are black box in nature. What data is used to train them, how has the data been used to train it is not known. This raises an issue of trust when it is difficult to understand how the black box operates. These are not technology issues but are operational issues. Foundation models, in particular LLMs and transformers, have been around for some years. The seminal paper, Attention is All You Need, was published in 2017, and IBM Watson has been using LLMs and foundation models to apply to NLP tasks. IBM products such as Watson Text to Speech, Watson Speech to Text, and Watson Assistant are good examples. Other vendors have made similar advancements. In 2021, Google demoed an early version of the BERT model that can carry a fairly intelligent conversation with a human user. It's key to remember that foundation model technology is not brand new and it did not spring into suddenly with ChatGPT. All that ChatGPT did was show the opportunities and vast potential of using LLMs for day-to-day operations. Its ability to generate well-crafted natural language answers to user queries shows the power of generative AI. However, there is a big difference between making something consumable by general public versus using it for enterprise production, dealing with sensitive, confidential, and proprietary data. There are many big concerns enterprises should understand, such as how was the model trained? Can it detect and minimize bias and hallucinations? Is it transparent? How is the model being monitored? Does it support regulatory compliance? Is it safe? Can it be customized? Now, addressing these issues is important for foundation models and generative AI vendors to provide a viable product for clients. Enterprise AI needs to be portable, efficient, and sustainable. But the largest models are expensive, energy intensive to train and run, and complex to deploy. By building on hybrid cloud technologies, IBM allows clients to optimize for performance, latency, and cost. watsonx is built on Red Hat OpenShift to allow clients to access and deploy their AI workloads in any IT environment, no matter where they are located. It can run on multiple clouds, including IBM Cloud, Amazon Web Services or AWS, and Azure, or on the client's premises and even on the edge. watsonx allows clients to move their AI workflows between public and private clouds seamlessly and safely, making it easier to securely process and store data on servers that they own or lease. This gives clients the flexibility to rapidly scale AI applications. If clients have data in cloud, IBM can bring it stack to them. If the client's data is on premises, they can train and tune their model there with the same cloud native and user-friendly experience. Clients can then deploy their models and performance inference on a variety of computing environments, be it on clouds, on premises to meet security or governance needs, or on the edge to meet the latency requirements. Together, watsonx.ai, watsonx.data, and watsonx.governance scale and accelerate the impact of AI with trusted data. Data that is governed and curated with business logic and classifications applied. This allows clients to train, tune, and deploy AI across the client's businesses, leveraging trusted data where they reside. The classic AI and machine learning capability of IBM Watson Studio is still there, accessible from watsonx.ai. So the three components of watsonx are watsonx.ai, watsonx.data, and watsonx.governance. IBM's strength is that watsonx is not just a foundation model and a generative AI. Enterprise clients get a complete suite of tools that provide rich data capabilities, hybrid multi-cloud, high-performance, structured, semi-structured, and unstructured. This is the data enterprises will use to fine-tune their foundation models. Governance of the foundation models and any modifications. We provide with transparency, accountability, lineage, and traceability, which are key items that bring high confidence in integrity, controllability, and safety of the generative AI features. Now, the three components that you can see on your screen are watsonx.ai, watsonx.data, and watsonx.governance. IBM watsonx provides a complete ecosystem that satisfies an enterprise's need for transparency, safety, and the ability to customize. Clients use watsonx.ai to perform AI workload tasks such as data search and discovery on their data in watsonx.data. Clients can use their own governed data in watsonx.data to fine-tune and train their watsonx.ai models. Clients can govern their watsonx.ai models, providing transparency, explainability, and control over their watsonx.ai models. Similar to IBM's cloud offerings, the watsonx family is all built on Red Hat OpenShift technology. Instead of a series of products with different capabilities and features, all these three components will share the same interface and user experience. In addition, this allows for common connectivity and integration, not just amongst watsonx but also other IBM offerings such as Cloud Pak for Data. watsonx.ai is a part of the IBM watsonx platform that provides foundation models and generative AI capabilities, plus traditional AI and machine learning modeling that clients have come to know. So there are some components of there are some important components in watsonx.ai. So these include Foundation Model Library, which includes many well-known models such as GPT, FLAN, and more, as well as IBM's own foundation models. Many of the models have been rebuilt on IBM's dataset to reduce model sizes and mitigate problems such as bias and other common risks. Then we have Prompt Lab. Prompt engineering is a way of helping foundation models become more accurate and precise in their response by providing some user interactions called prompts. Now, prompt engineering is an art and it requires practice. IBM provides samples of prompts and prompt templates, and the studio helps users to try different prompts and different models to get the best result. Next, we have the Tuning Studio. There are multiple ways that watsonx.ai lets clients fine-tune foundation models, providing additional data to further train the model. Changing various runtime parameters such as number of virtual tokens, learning rate, number of epochs, etc. These parameters can alter the amount of time and resources required to train the model when prompt tuning. We also have here a proven studio for machine learning. Clients continue to have access to familiar features from IBM Watson Studio in watsonx.ai, such as model operations, automated development, and decision optimization. In addition, team collaboration and data preparation is available for all models. A very important factor for quality generative AI models is the set of data used to train the foundation model. Random, non-curated data could introduce biased, inappropriate, illegal, and simply wrong input for models. One of the strengths of watsonx.ai is the quality of data used to train IBM's foundation models. The contents of the data IBM used to train its model consists of curated data from the internet, code, legal, news, patents, academic, and finance domains. Data used in IBM trained foundation models go through two main steps. One, data deduplication, where document ID is also generated, and second, data annotation, where cleansing, curating takes place, which includes actions such as language detection, hate, abuse, profanity, or HAP contents are filtered out. The document quality is checked, URL blocking is checked, license detection is done to ensure only appropriate content is used. Data is thoroughly filtered before it is used by watsonx.ai. With this method, clients can still provide their own curated dataset. Clients can be sure that all datasets going into watsonx.ai model building have been curated. watsonx.ai provides IBM proprietary foundation models. Unlike datasets used by various publicly available large language models to train, IBM uses enterprise-focused data collections that are curated to limit intellectual properties and bias issues, data that is transparent and optimized. IBM watsonx.ai provides the best of both worlds. Now, foundation models like ChatGPT are black boxes, and that is one reason why trust is difficult to achieve with these kind of models. IBM models are designed to address this gap to ensure model trust and efficiency in business applications. In particular, IBM's suite of model features transparent pre-training on trusted data, compute optimal model training and architecture, efficient domain and task specialization, and open source model. So what we mean by transparent pre-training on trusted data is that one of the most important trust factors for models is the data that is used to train the model, as we discussed before. There are two main issues: the quality of the data and the relevance of the data. Now, as we discussed before, having random data from the internet crawl would have injected bias, hate, prejudice, and it could inject all of that into the model. Whereas using any data can also bloat the model with parameters that the model may never use. IBM has therefore collected the largest known repository for enterprise relevant training data, covering a variety of topics like legal, finance, human resource, etc. This data has been then cleansed and curated to create a base pool of data to be used to build IBM models. IBM models have fully auditable data lineage and transparency, allowing clients to use them out of the box with trust. Next, we talk about compute optimal model training and architecture. Now, using this trusted data, what IBM does is build different models that can be applied in different scenarios. Some examples are the Granite series models, which are decoder only transformers and are great for generative tasks such as generating emails and marketing material. Next, we have Slate series models, which are encoder only transformers. They are small and compact but are better for non-generative use cases such as extracting and summarization, and may require task-specific labeled data to fine-tune. And then we have the Sandstone series models, which are both encoder and decoder transformers, supporting both generative and non-generative use cases. These are the best cost performance trade-off for generative use cases where the input is large. However, the generated output is small. Then we have the efficient domain and task specialization. Now, what that means is that IBM provides domain specific models where they are pre-trained with specific relevant data. This allows the model size to be minimized with focused pre-training for specific domain use cases such as finance, cybersecurity, legal, etc. And lastly, IBM has partnership with Hugging Face to provide access to open source models to clients. IBM will work jointly with Hugging Face and surface the best model suited to clients' business needs. IBM watsonx.ai's foundation model library provides access to a variety of foundation models, both IBM and open source. Foundation models have different architecture. We have discussed those architectures in the previous slide. The first one is the encoder foundation model, then we have decoder foundation model, and then we have a combination of both encoder and decoder foundation model. You can also see some other examples of third-party models that fall under these category. For example, Google's bidirectional encoder representation from transformer or BERT is an example of an encoder model. The GPT is an example of a decoder model. And Google's text-to-text transfer transformer, which is T5, is an example of an encoder-decoder model. Now let me introduce you to IBM's Granite models. Granite models are advanced AI models developed by IBM Research. They utilize generative AI to excel in specialized business domain tasks like summarization, question answering, and classification. They are built upon a decoder architecture which is designed to predict the next word in a sequence without requiring knowledge of the entire sentence. This architecture is considered unidirectional, enhancing efficiency in NLP tasks. The Granite models comes in different forms and sizes, recognizing that a single model will not fit unique needs of every business use case. With these models and watsonx, IBM enables businesses to be AI value creators. Businesses can bring their proprietary data to IBM-based models and build a model that is unique to their business and use cases. The data sets that the Granite model have been trained on are the internet, academic code, legal, and finance. The Granite model has three variants. The first variant, Granite 13B-V2, is an English LLM. This model has 13 billion parameters and is trained on 2.5 trillion tokens of data. The Granite 13B-V2 has two derivatives. The first one being Chat V2.1 and the other one being Instruct V2. Now the chat derivative model is optimized for dialogue use cases and works well with a virtual agent and chat applications. The Instruct derivative is designed to perform well on natural language tasks and can be customized for specific industries and domains via prompt tuning. The Granite 20B multilingual model has 20 billion parameters and is trained on 2.6 trillion tokens of data. And as suggested, this model has support for some European languages along with English. It supports French, Spanish, German, and Portuguese. Then we have the Granite 8B Japanese. This model has 8 billion parameters and is trained on 1.6 trillion tokens of data. This model supports Japanese. There are different ways to work with foundation models. Clients will find that in many cases, their models perform quite well out of the box. Foundation models, however, can be adapted quite easily to new use cases. There will be times when foundation models need some adjustments to really fit in with specific use cases, especially when clients have their specific languages or terminologies and have their unique way of organizing their data. There are two main types of training. At the prompt level, where none of the model weights are changed. So these two ways of training are prompt engineering and prompt tuning. In prompt engineering, clients can modify what is passed into the model, which is the prompt, so that the model can better understand the requirement of the task in hand. Now, prompt tuning takes this one step further. Instead of changing the prompt, the client will pass a set of labeled data. This is like using a few short prompt where few means up to 100 instead of a single digit of input and output examples. This provides some data specific to the client that is passed to the model to help it attune itself to the client's domain. This, however, does not change any model weights. However, it requires more work from the client to provide a labeled data set and is more expensive to run or test. At the model level, we have something called fine tuning. This involves passing a larger set of labeled data set as well as allowing the model to change and modify its weights. The result is a modified instance of a model that the client now owns. This requires access to a larger resource pool to rebuild parts of the model. This tuning method results in the best performance as clients can train their models with very specific data from their business to a very specific use case. In addition, the data required to fine-tune a model is only a fraction of what it would take with a traditional AI model. If clients have fine-tuning in mind, they typically start with a smaller foundation model. This helps to control the cost of building and running the model. watsonx.ai provides Prompt Lab for prompt engineering, which includes examples as well as prompt history, and Tuning Studio for prompting fine-tuning. The studio provides a workflow for clients to tune the prompt or model. The two arrows that you see on your screen on the extreme right side of the slide provides a quick contrast between the complexity of skills required for training, with prompt engineering being the easiest while fine-tuning being the most difficult, and the size of model required for good results. Prompt engineering requires the least amount of training, so generally requires a larger model for similar results are fine-tuned. Now let's just go over high-level differences between prompt engineering and prompt tuning. Neither prompt engineering nor prompt tuning requires a change to the underlying foundation model. So it's not as expensive to run as fine-tuning a model which updates its weight. Both can be used via application programming interfaces or APIs and can be used by anyone with access to the model. Prompt engineering is lightweight and an easier way to work with foundation models. Clients alter the prompt to instruct the model on how to respond. This is a natural language task and does not require any deep technical knowledge of the underlying model. The main difference between prompt engineering and prompt tuning is that clients must pass in a set of labeled data with prompt tuning. This means a much larger set of tokens are being used. With most models, this would mean that it is more expensive. The advantage, however, is that clients can start with a smaller model. Now we are going to cover prompt engineering and prompt tuning in some detail. Prompt engineering is available through watsonx.ai Prompt Lab, which helps clients to test out different prompts to get the best results. Clients can try 0 shot, 1 shot, and few shot. How to use prompts to get the best answer. Foundation models can be instructed to solve various NLP tasks through a process called prompt engineering, which is also sometimes referred as instruction prompting. Prompt engineering is a process of designing, creating, and testing prompts of natural language generation systems. Specifically, prompt engineering, also known as in-context prompting, refers to methods for how to communicate with LLMs to steer their behavior for desired outcomes without updating the model weights. At its core, the goal of prompt engineering is about alignment and model steerability. It's important to appreciate the term steerability. With prompt engineering, the underlying model is not changed. Now, why is it important? Generative AI is generating the next words or phrase based on what users have inputted or prompted. It is not answering. It cannot read beyond the words into the intent like a human would. It needs to be instructed properly to return the information desired. A prompt is a way to communicate with foundation models to pass additional instructions on how the model should respond, feed task-specific context to the model. Finding the right prompt is an art and requires experience as well as practice. watsonx.ai comes with a prompt lab which has an example library and interactive prompt building for clients to try out different prompts and find the best one. Now, there are different types of prompts that we have mentioned before. First is zero-shot prompting. Zero-shot prompting refers to general foundation model interaction with no specific instructions or specific data set to learn from. It just absorbs everything. Even with zero-shot prompting, a very large model can reasonably perform well in many use cases. An example would be just typing out a question. Question, what is Maximo? Next, we have one-shot or few-shot prompting. Now, this refers to cases where users provide additional training data. Now, this can be clarification or examples. This additional training data is provided to a model so that it learns what the user is expecting. These provide further instructions to the model. As these types of input are given at the time of query, they can be very specific to the task at hand and so can be quite effective to help the model to understand what is required. Prompt tuning, however, is more art than science. A two-shot prompting based on the one above can be a sample question, what is watsonx? Example answer, Watson Studio is IBM's integrated development environment to build, run, and manage AI models. Another example. The question is, what is DB2? The answer is, DB2 is a family of database management systems to run clients' mission-critical workloads. So what essentially you're doing here is that you're providing with the foundation model with a sample question and the answer that you're expecting. And then you go ahead and you ask the same question. Question, what is Maximo? The first two questions represent the two-shot prompting by giving two examples of the type of answer that is expected. Clients can also save and use prompts or change prompts using different parameters. This slide describes the features available from the watsonx.ai prompt lab. Now, clients may work with the interactive prompt building in many ways. One thing to note, as the screenshot that you're seeing on your screen is the most latest version of the UI that you see. If you take up this course maybe sometime in the future, the screen might not look the same. A prompt is a way for clients to interact and instruct with foundation models to provide answers. In generative AI, the model is not answering, but it is generating a response based on input and what it has been trained on. How one prompts the model can change the results in different degrees. Prompt engineering is the art of prompting in ways that a model can best understand and respond to client requests. The prompt lab is a part of the Watson AI user interface that allows user to perform prompt engineering and experiment with different prompts. Experienced clients can select the model of interest and experiment with different prompts to see what works best for a particular model. Clients can try the different shots that we've discussed earlier. Less experienced users can select different prompt samples from prompt labs and learn how the examples utilize one shot or few shot tuning. Clients can also set various parameters like greedy versus sampling. There are some sampling parameters such as temperature, top P, top K, repetition penalties, stop sequence, min, max, etc. Let's just go over a few of these sampling parameters. When we say stop sequence, what we're essentially doing is that we are telling the model to stop generating any more output once it encounters the specified stop sequence. Or the repetition penalty, to basically prevent the model from repeating their output, we give it some sort of a penalty. So the higher the penalty, the less likely the model is to generate repeating phrases, because it's going to be penalized much higher. Now note that unlike traditional AI tasks, generative AI creates a response best suited to its understanding of the question. Let me reiterate, this requires experience on the user's part to learn how to effectively prompt the model, as it needs to learn and understand enough of the intent of the request. Using the prompt lab discovers this experience. Now, the best way to learn how to pass good prompts is by examples and practice. The watsonx.ai prompt lab provides many such examples for various NLP tasks, such as summarization, extraction, generation, classification, etc. One very interesting feature that the watsonx.ai platform has is that the prompt lab keeps a history of all the prompts. As a part of your learning experience, users may want to go back to the previous prompts to see what has worked better and what they could tweak. The UI keeps the track of past prompts so that users can easily move back and forth. Once the data scientist, data engineer, or any user has found the best prompt, it can be passed via an API or Python notebook to the model. It can be used to automate tasks for other users. While clients can prompt tune and fine tune their models, that requires work and resources. Prompt engineering is a way to evolve a model for the needs of the clients without model rebuilding or a lot of label data. Now, there are different types of prompts. Let's just explore some examples. IBM watsonx.ai supports prompt engineering with easy to use interface called the prompt lab, as we discussed earlier. And we've also discussed that the prompt lab provides some typical requests. Now, clients can easily modify or put in their own prompts using this simple interface. Clients can always move back and forth to the earlier prompt using the history, and can also save their prompts, the best ones that is, for later use or reference. Beyond adding prompts or inputs, clients also have the choice to modify some parameters that affect how the model operates. These can vary depending on the model, and they may include the following: choice of the foundation model to use. Obviously, some are better at certain tasks than the other. The type of decoding. The clients can choose between greedy or sampling. With greedy, the word or token with the highest probability is selected. Most LLMs operate in this way. It is the simplest form of next word prediction. In sampling, the model selects a token using a random weighted strategy across the probabilities of all tokens, resulting in the possibility of returning a less probable answer. This is used for creativity and to avoid repeating words, but can cause the LLM to wander into areas. There are some other sampling parameters that we have discussed before, such as temperature, top P, top K, repetition penalty, stop sequence, min, man, new tokens. Now, the prompt lab is great for performing zero shot to few shot prompting. However, in many cases, this may not be enough. Enterprises also have the option to provide specific training data to the model using the watsonx.ai tuning studio. This slide shows an example of prompt and prompt tuning. Now, on the left side of your screen, you can see a simple prompt asking the model to write a thank you note. The model does a very good job of writing a thank you note. However, the thank you note should also include an invitation for the next step. Now, on the right side of the slide, the client adds the phrase expectation, discuss business opportunities, to the prompt. The model figures out what is required and provides a modified email that provides the needed content. Through this exercise, clients learn that they can pass in tokens with expectation to get the model to provide additional content. This can subsequently be used via API calls with different values to create emails and desirable content. This slide shows an example of prompt engineering for a customer complaint information extraction task. Now, on the left side of your screen, initial instruction was given asking the model to list all the issues from an irate customer complaint. Without the training, the model attempts to complete the task by guessing which of the options is likely to have these complaints and conclude that the issue relates to retail banking. However, this is not what the question is asking for. On the right side of your screen, you can see the modified prompt. Now, the modified prompt is in the form of an example being passed into the model, and this is one-shot prompting. The example provides one similar complaint and the expected output, which is a list of issues that came from the input text. What this is doing is teaching the model that this query is not asking for the best match option from the complaint, but rather a list of specific issues raised. The next slide will show you what the model will now do with the new prompt. So this is a continuation of the previous slide showing how prompt engineering works. So on the left side of the screen, you can see the same question answer. Now when you run the query again, the model successfully produces a list of issues from the complaint text, which is what we are looking for, which is what we were looking for. Now beyond prompt engineering, which is manually adjusting prompt to send to pre-trained models to get answers, client may want to feed a small set of label data to update the foundation model to better serve specific needs. With watsonx.ai, clients can supply their set of data to train a foundation model. These trained models belong to the clients and are for their use only. With the tuning studio, clients can perform prompt tuning. Prompt tuning takes the next step beyond prompt engineering. Specifically, name the finished model. Then clients can create their own naming convention for models. Then select the models that they want and easily drag and drop to provide their own data. Now the data can be in a JSON format, and the clients can simply point at a directory where the files are or drag and drop into the studio. The tuning studio allows clients to try out prompt tuning and fine tuning. With prompt tuning, clients can choose a model and use their own specific data to enhance that model. While foundation models are very capable at general level, businesses have their business terminologies, specific workflow, and specific output that they expect from queries. In prompt tuning, clients can feed a set of input query and expected query pairs pairs into the model. This teaches the model to better understand the intent of specific questions and how to generate the most relevant output. As clients pass data into their model, there are also parameters they can modify in enhancing the model. Keep in mind that this can be a very involved and an expensive process depending on the model. Clients can consider using a larger batch size and a smaller number of epochs to control the training time and cost. Now, there are two important things to note with prompt tuning. No model weights are changed with the process. Clients are enhancing the model but keeping the original parameter weights. With the proper set of data, this can achieve near fine-tuned results. This is important. While fine-tuning may give the best results, it is much more expensive as the model is updated. Prompt tuning also avoids catastrophic forgetting. That is, the underlying model has so much weights modified that it no longer resembles the original. This essentially destroys the reason why the base model was chosen in the first place. Another advantage of IBM watsonx.ai is its partnership with Hugging Face, the leading open source platform provider for machine learning models, including generative AI. This partnership allows clients to access the latest and greatest open source models from Hugging Face. It demonstrates IBM's dedication to open source and a commitment to making available the best open source. Clients can find and use the models that best fit their business needs. Note that for best fit, clients should keep considering the following. Look for models that can perform the task at hand. Amongst those models, a fine one with the right size can perform satisfactorily. Clients can always go with a huge model, but it will be more expensive to run. Options are therefore very important. There is a tremendous value in the data that businesses collect, but access and availability to that sensitive data remains an ongoing obstacle that impacts speed to market, privacy risk, and overall ability to innovate. This influences what insights you can collect and how much data you can share, how much you spend on data, and how many AI models you can deploy and how quickly can you do so and how effective they are. IBM synthetic data generator on watsonx.ai helps tackle this problem by enabling businesses to generate the synthetic tabular data that they need using existing data from a database or file or using a custom data schema. When using existing data, you'll have masking capabilities to remove or hide particular table or columns prior to generating synthetic data, as well as the option to apply differential privacy to ensure minimal privacy risk. This slide shows some of the key personas that watsonx.ai caters to, such as data scientists, developers, and analysts. It must be pointed out that watsonx.ai does not stand alone. There is also watsonx.data and governance, which supports additional personas such as CTO, security officers, data analysts, and business analysts. Now, it's one thing to have generative models. It's another thing to be fully confident and trust these models given how well documented these models can misbehave. watsonx.ai can work with watsonx.governance to provide the type of control and transparency and explainability that makes generative AI a winner. watsonx.ai provides generative AI models that can generally enhance what data or business analysts can do with the data or with their workflow. In turn, watsonx.data provides trusted, curated data for the training of these models, providing added confidence for how the models are updated. watsonx.ai is a part of the new watsonx platform, and they are designed to work together within a larger IBM software ecosystem. First, automation. watsonx.ai brings the power of generative AI to improve automation accuracy with governance. In addition, its auditability provides trust in the process. Second, data. AI and data have always worked very closely. watsonx.data and watsonx.ai are highlighted here, but these relationships are not inclusive just between these two. watsonx.ai allows clients to tune it with their own data. However, that should be governed and curated data and not anything arbitrary. watsonx.data provides that capability. With access to data available in object storage that can be securely used to build models. Extensive generative AI is used to analyze all types of data to extract information, such as summarizing logs to highlight warnings and flags on various contents in watsonx.data. Hybrid cloud. watsonx.ai is built on top of Red Hat OpenShift, so it can be made available anywhere when the client needs it. It provides generative AI to match clients' business requirements, especially in regulatory compliance. And lastly, security. watsonx.ai has many applications in the security area. It creates a unified security workflow across the multitude of security tools. Most companies need to manage and reduce incident response times and protect data across the hybrid cloud and simplify compliance. Now let's talk about some of watsonx.ai's competitors. Since ChatGPT became a household name in 2022, the field of generative AI has become crowded with multiple vendors putting out their offerings as business demands for this technology have simply exploded. Now, this slide lists some of the top competitors. The field of generative AI is fast changing and new players are coming on the stage quickly. So this is not a comprehensive list, but simply the ones that are currently considered top competitors. There are two main types of competitors discussed in this presentation: the hyperscalers, which are the traditional AI vendors, and the others. Now note that for the hyperscalers, their generative AI platforms are only available on their respective cloud and nowhere else. Amazon Web Services or AWS recently announced AWS Bedrock, which is in preview, Azure OpenAI Service, and Google Vertex Generative AI Studio. The other non-traditional AI vendors are AI21 Lab. It's a vendor from Israel. Its models Claude and Claude 2 are GPT competitors. Anthropic messages on 3 H's: helpful, honest, and harmless. Cohere provides generative and embedding models. The embedding models are multilingual and support well over 100 languages. And NVIDIA, probably much better known as graphical processing unit GPU vendor. OpenAI and ChatGPT are not on the list for two reasons. ChatGPT is a chatbot. That is not the top focus of IBM's generative AI. IBM's main audience is enterprise businesses that require a lot more security, control, and guardrails when using generative AI, not required for general chatbot like ChatGPT. Context is important when discussing generative AI. With enterprise businesses, the safe management of the platform is just as important as the capability of the platform. It is not enough to look at what a vendor offers in ways of foundation models and generative AI. It is important to discuss other things like governance and how to manage the data used to train and integration with traditional AI. Terminology is important as not all vendors speak of generative AI in the same way. Google, for example, uses model tuning for fine tuning. A very important decision point is inference cost. How much does it cost for a client to perform a particular task? The table that you see on your screen highlights the cost difference between IBM watsonx.ai and some of its competitors. The task at hand is using a large language model to summarize a 30-minute call into a one-page summary. This translates to a 6,000 token prompt input and 666 token completion. In the table, you can see that the price per 1,000 tokens cost for input and output are provided for using the Llama 2 chat model in both watsonx.ai and Amazon Bedrock, as well as the same costs for OpenAI GPT-4 and OpenAI GPT-4 Turbo. The total cost is the sum of input tokens and the output tokens. So in all of these columns, you can see the price per 1,000 input tokens, the price per 1,000 output tokens, and the last column shows the total inference cost. Clients have the best cost using the Llama 2 chat on watsonx.ai. So this page puts into perspective the previous slide. Recapping the last column from the previous slide, Llama 2 chat's inference cost on watsonx.ai was 0.011. Llama 2 chat on AWS Bedrock's inference cost was 0.013. This is 1.11 times the cost of watsonx.ai, or for watsonx.ai it's 11% less expensive. GPT-4's inference cost was around 18.3 times the cost of watsonx.ai. GPT-4 Turbo's inference cost was 6.6 times the cost of watsonx.ai. For clients with many users and each running multiple tasks, this adds up to a huge amount very quickly. Now this slide shows great results from a client proof of concept with IBM watsonx.ai. The client is now adopting watsonx.ai for summarization and other tasks after the successful POC. Clients were already doing a POC with OpenAI on two use cases: retrieval augment generation, which is RAG, and summarizing meeting transcripts into a specific JSON structure. The goal of the IBM POC is to prove to the clients that IBM watsonx.ai can perform at par with OpenAI with smaller and more compute efficient LLMs and hence a lower cost. The IBM team worked with many clients to understand their token utilization and determination to use the Llama 2 13B chat model. The results showcased many watsonx.ai advantages, including the client agrees that the much smaller Llama 2 13B chat model provides equivalent results as OpenAI 3.5. A 33% savings when compared to using GPT 3.5. watsonx.ai provides a secure and dedicated environment with a robust LLM model workbench and tuning platform, making it easy to learn and perform prompt engineering and generative AI tasks. It can also be hosted within the client's firewalls. watsonx.ai provides a simple, single, and standard API SDK entry point for various models. The client can easily create notebooks, change models with a simple click, save histories for their prompt engineering steps. Here you can see how clients can move from their existing portfolio up to watsonx components. Note that some of these existing capabilities, especially in the AI governance areas, are being enhanced, while the entire area or generative AI foundation models are new in watsonx.ai. A data lakehouse is new in watsonx.data. This slide describes how clients can join the watsonx pilot program. So what you see on your screen is what does IBM offer, what value do clients get, and what is your commitment. Essentially, we talk about the investment that IBM is making into its clients and what returns they can get in return. There is a 3-step path to watsonx.ai adoption with the technology expert labs. Step 1, sellers can attach pre-scoped offerings to all new license sales. Step 2, consider expanding your deal with Expertise Connect. Step 3, be sure to engage your expert lab services sellers early in the software sale. The table on this slide shows the offering details, including price, duration, and transaction details. Sellers can click on each offering to learn more about the offering, including the business challenges it addresses, outcomes, and a sales kit with everything you need to sell. The sales kit includes a client deck, a client flyer, enablement deck, a seller brief for an all-in-one view of the offering, and technical assets needed to sell this offering. It also includes valuable information on how to transact. On the left side of your screen are important contacts seller can reach out to if sellers have any questions about including these offerings in the deals. This slide presents the pre-scoped services offerings available from technology lab experts. The build offering is the recommended minimum attachment for all new license sales. It includes services to help clients quickly get started with watsonx.ai by implementing an initial virtual agent use case. Expertise Connect is the perfect service to include in all deals and take over after the initial build to help clients grow and expand their solutions. If IBM's predefined offerings don't fit a client-specific needs, IBM can offer bespoke services tailored to a client-specific requirements. There are 3 different ways sellers can team with IBM Consulting to get clients to start leveraging watsonx now. The first is a free half-day strategy briefing, which is an initial discussion to learn about IBM's generative AI watsonx POV and determine if generative AI can be leveraged now within the organization. The next is a garage design session, which is a collaborative session to determine a watsonx.ai roadmap for transformation. And third is a pilot program to deliver results based on the selected use cases leveraging watsonx.ai capabilities. Challenge yourself to deliver a watsonx briefing for each of your client. Prioritize using entry points just discussed. Establish IBM's point of view on generative AI and hybrid cloud before competitors do. Sales Kit will help sellers follow the client engagement model with videos and client presentations, which is an extremely helpful one-pager and a frequently asked question page. In partnership with product management to get head start on skills, the watsonx.ai activation team on the technical side in each market to assist sellers along with IBM's data and AI sales plus tech team. You can also earn the watsonx.ai sales foundation match. There is a material from Worldwide Enablement that covers AI Fundamentals L1, watsonx L1, and the watsonx.ai, including IBM's foundation model, story, differentiation, competitive objection handling, and entry points. And look out for upcoming education and try to get it done early to get ahead. So now on your screen, you can see the different resources that you can make use of on your journey with your clients for watsonx.ai. Thank you for staying with me and getting to the end. This is a lot of information to consume. However, we have provided you with some of the best resources that you can use to get started. And good luck.